how to improve the efficiency in a power plant. So first improvement of efficiency is definitely the operation group in the power plants. They are doing by daily operations and trying to follow the daily methodology how to improve. But the next steps which the software tools can do is auditing or mapping the plant using different thermodynamic modeling toolkit. That's offline exercise, can be done in the power plants. And in Steag, we have our proprietary tool called Epsilon. It's a first principle-based thermodynamic tool, which can be used for mapping the power plant and give a one-time or periodic advices. Where is the deficiencies of the power plant, where can be improved, performance can be improved. Then, of course, the more effective solutions which can be provided is the online optimization tool. In India, Pardo is not a brand name, but in India it's a popularly known name now because of thanks to NTPC where the specification is defined. Basically, Pardo stands for Performance, Analysis, Diagnostic, and Optimization. And also it can be enhanced, as Mr. Andy was saying that, there are a lot of data we are collecting from the power plants and all. So different statistical process charts or methods which can be utilized to filter out the data and give more predictive, predictive solutions. In this case, we have our online fault detection system using statistical process methods and fault trees. And of course, we have we can provide lifetime monitoring for SR1, which is for the thick wall components for the maintenance purposes. So I'll very quickly go to the offline tool. I don't want to go very detailed. We have a small stall here, which can be, if you're interested, you can view there and we can give full demo to the Epsilon software which we have. But I'll just very quickly tell that what are the applications offline tool can do here with our offline tool. First is you can do the power plant design for a new power plants. You can do the mapping of the existing power plants, and also you can do planning for renovations, which was the topic yesterday also, that a lot of power plants in India were thinking of renovation. So this Epsilon can be used as a tool before you go for renovations, to study of the power plants, whether the things can be improved. So these are the modeling technique. We don't want to go into that detail. So Epsilon has a lot of histories of 20 countries we have. We have a history of 20 years, and it's a tool. It's a tool developed by Steag, and we have a continuous development process. We have almost more than 700 licenses of Epsilon has been sold worldwide. So it's a very useful tool which can be used for this kind of solutions. I don't want to go into detail of the calculation programs also, so many things can be done. The interesting thing is it's not for only thermal power plants. You can see that Epsilon can be used for fossil, nuclear, combined cycle, regenerative cycles, solar, refrigeration cycle and all. So this is an offline tool, can be used for a lot of power industries, not only for thermal. I don't want to go into that. That is a graphical user interface just to tell you that all these individual components of the power plants can be modeled individually, and these objects are available there. So this is also step of the power plant modeling, which I don't want to discuss here. Again, a lot of off-design calculation. Case studies can be made. For example, what is the effect of a particular parameters in a power plant if you want to see in a thermodynamical model. So that can be done using Epsilon tool. So that's just a small example there. So it's a typical model in power plant, very simple cycle. You can say for a typical 210 megawatt plant, which can be done using Epsilon. You can see a model where all the components like turbine, boilers, heaters, aerators, everything is modeled, and you can do a complete thermodynamic balancing of the power plant using Epsilon, and you can see all the process parameters and also do different case studies. So my next topic is the online tool. Of course, offline exercise can be done once or twice, but since we are talking about every bit of calories, we are talking about every 0.1% of efficiency improvement in today's scenario, where there is a problem of coal, where there is a problem of availability of the power. So any applications which are online is definitely going to help for day-to-day improvements in terms of efficiency or hit rate. So we are proud to say that Steag has a framework agreement with BHEL for supplying online optimization systems we call Pardo, and we have a working arrangements with BHEL. We are working from 2002, but we had a working arrangement started in 2008, and now we are continuing as a proud partner with BHEL. And you can see that what is the history in India, how it is generated, although it started in 2003. Now we have 72 units ordered on us, and we're again proudly, we can say that most of the orders are from BHEL, through BHEL, and now we have also 23 units successfully commissioned. Because a lot of units are in 2012, 13, in the coming years, it is not yet commissioned. So it is under commissioning, the Pardo is under commissioning. And also, we are very happy or proud to be said that in NTPC, we're thankful to NTPC that they have considered our Pardo and they make a standard. The specification has been standardized based on the supply which we have done, and then it is been included all the future power plant also, including supercritical power plants. And as you know, BHL is nothing to say about that we have framework agreement with BHL. These are the some of the plants. As you can see in the top, the Simadri, which was commissioned in around 2003, 2004, and we have successfully do the site actors in 2005. And after that, it is really a lot of projects. Apart from NTPC, we have a customer from Mahajan Co. Then we have Cape Karnataka Power Corporation. We have installed in Rajasthan Vidyut Nigam. We have gone into Sri Cement. We are under commissioning with DVC Maithan, with Tata Power collaborations. In Gujarat, we are there. Chhattisgarh, Tamil Nadu. And we can say L&T also. Recently we have got the order from L&T for Rajpura 2 into 700 megawatt, supercritical. So why people are talking about Pardo? What is the requirement of Pardo in the industry? It started, of course, started from a vision from NTPC in 2002, 2003, but definitely it is emerged as a product in the country today. So CA and other regulatory authorities are trying to emphasize this kind of software solutions which can really improve the efficiency of all. So I'll just highlight the major benefits or advantages which Pardo can provide today in today's scenario. I'll go into the detail of this a little bit in the further slides. But first important thing is any calculations or any optimization solutions unless, because this is software solutions which is online, we are taking data from the existing DCS and all the inputs are required for Pardo is taken from DCS. So unless you validate the data or measurements, the results which are coming out of the system is also not reliable. So we have to validate the measurements, and by doing that, what advantages we are getting that we are improving the quality of the measurements of the by data validation. So the power plant CNI maintenance control instrumentation maintenance group can have a reports of the measurements which are not which are implausible. So that helps to improve the quality of the measurements. Then of course the most important thing what Mr. Andy also said, that plant monitoring systems. So this boiler, turbine, condenser and all other components, the evaluation of the plant components we are providing as a performance, current performance. But what more we are providing is not only showing the current performance, but also we are providing the best achievable. See, normally what happens in normal performance calculation, it can be provided that your existing performance and the design performance. But here we are talking about best achievable performance. What does it mean? Best achievable means if it is designed, then of course there may be a big gap between existing performance and the best achievable performance. Our Pardo or performance monitoring systems calculates online from a thermodynamic based model the best achievable based on the current cold, based on the current ambient conditions. So whatever you would like, you can achieve in the current scenario, that is what is given as a best achievable. So that helps operator that where is the deviation happening and where he is losing the money. So that should be the focus for the operator to give alert every time whenever he is looking at the systems. System provides him the current information about the losses he is having in the monitor. I will go into the next slides when we will be providing. So that helps for him to give an advance notice. The third point, which is most important here, is the optimizations, which we are talking about and which we are successful in here, is the optimization of unit operation using our soot blowing optimization module and Setpoints module. So I'll go into these individual modules because optimization gives you direct benefits. If you really follow the advice of the systems, optimization gives you direct benefit in terms of return of investments. Then of course you do a lot of what if scenarios like different case studies you can prepare. And the other important information is also the reports. Because today's scenario that people are busy at the power plants and also so many activities are there. So this kind of software solution sometimes becomes a little bit burden to the power plant. So unless you provide the proper report with the requirements of the different departments, because Pardo is not only for the operations group, but it can be utilized in different levels, including the management, including your maintenance departments. So each department's requirements has to be identified, the system can identify and can prepare customized reports, so which can be used as a management dashboard, which was talked by Mr. Andy also. So we can prepare a management dashboard by which, where all this summary of the information or summary of the performance can be displayed there, so that all these corrective actions can be taken concretely, so that everybody needed to see all the calculations or all the optimization reports which Pardo is providing, but it can be department-wise, it can be it can be level-wise, it can be given as a separate thing. So that is also one of the important things. Ultimately, the overall objective is to improve the efficiency. So these are the modules which we have. I don't know, I will not go into very detail about that. Just to tell you that there are 5 varieties or 5 list of the things which are there. First is the base module, which is shown in the white background. You can say the database management system, which is our center, which is the heart of the systems, where all the data from DCS is coming and all the calculations is stored there also. So that is the first thing, and then it is going to the data validation in the left side if you see. Then we are presenting the data in a visualizer, because that is the most important thing for the operator or the user. User need not see all the details inside there, so these results need to be presented in a proper way, so that operator can see or user can see the results in a very user-friendly manner. Then we have for the base module, then we have fault detection module in the right top. If you see, there are 2 modules: statistical process control, and there is a fault tree, which is a basically together you can say it's a fault diagnostic module. Then we have an epsilon module, which was again as a tool we have used for creating the online model also. So it's our own tool. It's a first principle based proprietary tool which is used for making the total thermodynamic model of the power plants. And of course, in the right corner, if you see performance monitoring and water analysis, that gives you the current performance. And then we have a physical conditions module like metal temperature and lifetime monitoring. So that is roughly the module list which we have, and it can be selected. Basically, depending on the requirements of the power plants, depending on the requirement of the utilities, it can be selected. The module can be selectable. So I'll go very quickly, not taking much time. The SRX is our central database management system used to store the data in a different archive format, so that immediately you can, it's like in DCS, immediately you can archive 5 minutes data or 1 hour data, every kind of archive is possible, and also be presented in a user-friendly manner. The data has a good interface to the other third party like Excel, ADIN or HTML list, it can be presented, and it shows in a traffic light system, like it is showing in green, that means everything is fine. If it is yellow, this is alarming. If it is red, it's really alarming status. So this is roughly how the screen look like, typical screen. The most important thing in this kind of system is the validation of the data, because unless you validate data garbage in, basically we will produce garbage out. So we have a very strong data validation method. It's a 3 layers of validations which has been done. I will not go into very detail of the technicality here because of the time limitations. First is the neural network based check. That means neural network is like a human brain. So we train the data using neural network tool first, so that all the input data are stored there in the neural network. And whenever one of the sensors are not working correct, so it recollects from the memory from the past trained data and gives you plausible replacements from the current existing plant operational data. The second is plausibility check based on the range of the values. So we provide a range check validation also, where based on the current load conditions and everything, the input data can be validated. But the third and the most important data validations which we provide is the first principle based thermodynamic modeling tool. As I said, we have epsilon, which gives you the first principle mass energy balances. It also has inbuilt VDI 2048 standard. That means that's a validation standard internationally recognized. This epsilon provides that kind of data validation. That means all point of time, whatever calculation we will be providing is based on that mass and energy balance procedure. So I will not go into detail how it looks like. You can see the data trees, that how the validation has been done. So it's so visible. It's visible to the operator or user that how the data validation is done using this process. And just one study we have done, that how our data validation using these 3 layers of data validation which I just now described is accurate enough. If you show the below line, the green and the blue, that data reconcile value from Pardo and the precision measurements, if you put for the one instrument, it matches very close to each other. That shows that it really improves the measurement of the power plants. So these are the kind of report which is provided through Pardo in data validation report. That means the CNI or the CNI maintenance group can look at the reports in a daily and then see that which are the measurements which are not plausible. For example, if you see the last one, there is a value difference of 184.1 and 183.9. So even it is not significant for this, then you not do too much of things. But if it is really deviated from the raw value to the validated value, then it will be showing in a different colors. so that the maintenance group can take care of those measurements. So it gives you a screening process of the measurement. So performance monitoring, I already told that it really compares the actual performance of the parameters to the best achievable parameters. So that gives the always to keep the operator say that where are the losses which are happening, which are the zones and how much losses. Here you can see in the right side, we are providing the monetary loss. That means it not only provides how much steam or how much coal, that doesn't justify that which are the areas he need to be concentrated. But if he shows in a monetary loss, so that means it gives a warning to the operator that these are the areas he needs to take care. And this system is not a critics to the operator, but it's really a helping tool that he needs to really take care of those sides where there is a bigger losses. If it is small minor losses, then maybe he can take care, but maybe in the little bit later. But first, the bigger losses is identified straight away online, so that operator can take corrective action there. One of the important benefits or beneficiary module which is covered under Pardo is called soot blowing optimizations, which has been really used quite intensively here. So soot blowing module meaning especially in the thermal power plants, you have the soot deposited in the different heating surfaces. And there is a standard procedures followed in most of the power plants to do the soot blowing, to remove the soot deposited in the different heating surfaces in at particular intervals. So this module helps you to optimize this number of soot blowing, so that you don't soot blow too much or you don't soot blow too less. So how it predicts, because we have thermodynamic models, we calculate the efficiency of the fouling surfaces efficiency online from the first principle model, and then we take different process criteria. Like you have, it cannot be a general solution, because every plant can have a different problem. Some plant has a metal temperature problem, some plant has a spray problem, some problem has a emissions problems. So the advantage of this system is this all operational constants can be integrated in this soot blowing module, so that the solutions which is provided by the systems is plant specific. So it's not a general solution, but it's plant specific solutions, so that this advice from the system can be followed by the plant. So the involvement of the plant operational personnel is required during the customization process of the soot blowing. So you can see that in the top, in the economizer, it is also showing the color systems. The red meanings that it is telling that you to do soot blow. So if you see in the top, second from the top is economizer, where it is showing in the red colors, all the blowers. So it gives a level-wise soot blowing advices. So here it is telling you to soot blow. And in the previous slide, if you see, there is a yellow color. So yellow meaning you have to wait. So it's in the queue. So once the red is completed, then you will go to the next steps. So it doesn't give soot blowing advices simultaneously. So a lot of operational constraints is taken care by the system, which is configurable and is very easy to change by the user. The another optimization model which gives you a lot of benefit as well is set point optimization, which the target is the improvement of the heat rate, which we are talking how to reduce the losses in terms of the plant performance. So heat rate reduction is the objective of this module, and all this, if you see in the left side, all this actual value is been displayed, and there is optimal value which is been generated by the systems. So idea is, suppose you are operating your power plant today in one particular point, and the system is giving you advice here. That the idea is not to jump from one operational regime to other regime in one step. So system gives you the incremental way to move to the other envelope, so that it is not advisable to give the optimization recommendations in one go from one regime to another regime. So that system takes care so that your change is incremental and it is possible to implement, so that you achieve, say after a certain point of time, the desired heat rate levels which can be achieved by the power plant. And also, in addition to this, the existing set points, we also provide the mill optimization as a combination with set point, so that the mill combinations, which is suitable mill combinations to achieve the heat rate, is also provided along with the mill loading. So other important module which is helpful in the power plant today's scenario, because you know that there are a lot of tube leakages which is happening in the power plants. So this module, metal temperature module, basically we computes the different tube metal temperatures from the model, and first of all it gives you a calculated value all the times, because we have seen in the power plant this metal temperature measurements does not last very long. So if you have to, the operator has to see a temperature profile across the tube, then this type of calculated values can be taken as a temperature profile as a reference value by the operator. That is one utility which can be directly generated from the systems. The other things which is provided is the hotspot. Hotspot is not really like a hotspot, but what we are presenting here is the maximum metal temperature calculated by the systems. So it gives you every time that which is the tube, which is the assembly, which is the location of the point where the maximum temperature is happening. And you can make a trend, because system is very user friendly to make a lot of trends. Then you can easily see that where your maximum temperature is happening. And if it is continuing for a longer period of time, then you can have a look on that particular tube and that particular area during your annual shutdown. So that gives you direct indication, and it can give it is not directly leakage detection module, but it can give a indication that maybe if this particular hotspot is happening for a longer period of time, it can cause a leakage. SR1 is also another module which gives you lifetime consumption of the thick wall components like drum, superheater header, reheater headers. It basically it's a TRT based systems which is and it calculates the lifetime consumption based on the fatigue and creep, because in the initial period of power plant, especially operations, before going into the final commercial operations, it goes a lot of startup and shutdown, the power plant. So all those instances it captured, the data has been captured, and it calculates what is the life consuming continuous basis. So it's not it's online solutions, but it is a solution which results can be used for a long-term maintenance planning, that when this equipment or this header needs to be changed. The other important advanced module which we are providing as add-on to the Pardo is the fault predictions. It's not the fault, it's predict the fault before it happens. That is the most important output it is giving. That means there is especially the rotary equipments like fan, like pumps, where there are vibrations or winding temperatures. If it is this particular systems, because a lot of measurements are coming as the input data. So if you take the trend of this measurement data, it is very difficult to find out whether there is a sharp change in the value. So we need to have a statistical process, sophisticated statistical methodology by which you can detect the sharp increase or decrease of the trend. So this statistical process control identifies this change in the trend. As you can say that there is a plausible air ingress has been identified at the end, and it gives you early fault prediction, so that you can take the corrective action before the fault happens. So these are the different KPIs which can be included in the statistical process control method. For example, vibration, bearing temperature, oil temperature, as I said. And the last but not the least modules in Pardo we are considering is the fault trees. That means that is the post-mortem system. For example, if fault happens, one fault happens, and what is the root causes of the fault? Possible root causes can be identified through using these fault tree modules. So we have focused on the Pardo so far, but as a Steag we are also providing other this particular Pardo is basically optimizing the processes. So we have the other software systems for plant optimizations. For example, we provide the operator training simulators to improve the skills of the operator by giving the training on the simulators. So we can provide the training on our simulator which we have. Also, we can develop a simulator for the customer for a particular power plants, and we can do different simulation studies also using our simulator toolkit. And also, we have a computer-based maintenance management system, which is also is quite widely used here. And we have at the moment we have implemented at our power plant at Jharsuguda, which is really our maintenance group is getting a lot of benefit out of this. So I don't want to go into detail of the system, but just to have a little bit impression that how it looks. Basically, this is the simulator. You can see that in the upper side there is LVS or big, large video screens, and there is the operator screen. So it looks like the look of the simulator should be, feel and look should be similar like the power plant, so that operator need not to be, in the power plant they can be trained in the simulator with the same look and feel of the HMI as well as the displays. And other system, as I said, is the maintenance management system for the SI. So there are a lot of modules which basically can help the maintenance of the power plants by making a lot of interdepartmental communication easier. So thank you for your attention, and since I have not covered these two modules or any other queries, since we have a short of time, please visit our stall, and we have a live demo. You can see that for all the modules which we have. Thank you once again.
Thank you, Debashish.
Thanks.
We had excellent session in the morning. Started with a message from the AP Gen Co-MD, 4 keynote presentations, followed by 3 technical presentations. And all the presentations have been excellent. And because of the paucity of time, we are not allowed the question answer session to be taken. Any of you have the questions on any of the speakers, please put in a piece of paper and we'll try to fit them into the panel discussions, provided we are able to get the time into the panel discussion. Because in the afternoon also we have very strong presentations, about 8 presentations after lunch. And one more thing is the ARC will upload all these presentations to the web. You will get the link for getting all the presentations, so you don't have to worry about the presentation material. It will be uploaded. And as Andy said, it will be somewhere in the cloud, but you will get all the presentations. Okay. And we are slightly delayed for lunch, but we want to start the session back at 2 o'clock. Please cooperate, and then let's hope we join back at lunch, after lunch at 2 o'clock. Thank you.